Let's get started. So welcome to our live training session. The class today is called Introduction to State Machines. And so we're going to be looking at creating a finite state machine using C# scripting. You may have seen state machines if you've worked with Mechanim, for example, which is a state-based system. In this case, we're going to be scripting our own. And so basically, what a state machine is it manages an object that can change state. So the example we're going to do here is an enemy AI example. If you can see in the picture there, we've got the enemy with the little cube over his head. And so he's going to have 3 states: patrolling, alert, and chasing. And so our state machine is going to allow him to transition between those states based on things happening in the game. So let's actually just start out. I'll show you the finished version of what we're going to do, and then we'll double back to the beginning and set it up again. So you should now be seeing the Unity editor on your screen. And so I'm going to play my scene here. And so this is a modified version of the survival shooter project. And if we walk over here, where's he gone? Oh, he's walking around. Okay, there's our enemy. He's got a green cube on top of his head. There he is. And now when we get into range, the cube turns yellow to show that he's gone into alert mode. He alerts for a second, looks around, and then doesn't see us, so he goes back to patrolling. And green is patrolling. Now, if he sees us, he turns red and pursues us, but if we get behind cover, he goes back to alert mode for a second and then goes back to patrolling. And now if we just stay within his line of sight, he's just going to chase us until we get out of line of sight, at which point he'll go back into alert mode and then return to patrolling. So this is the example that we're going to use here with this simple enemy AI example. But one thing I want to emphasize for you with this idea of state machines is that you could use this same design pattern that I'm going to show you to manage all kinds of things in your game. Any object that changes state. So for example, we could use this in a game manager type situation to say, okay, we're in our main title screen, we're in a loading screen, we're in a gameplay screen, we're in a paused screen, and many other scenarios. So what I'm going to do is I'm going to take us to the within. So I've already imported the assets for this. You can get them by going to Window, Asset Store, type in Survival Shooter. I also linked the project in the chat. I'm going to just move ahead because there is actually a fair amount of stuff I want to cover today. So I'm going to go a little bit more quickly than I do sometimes. And so what we're going to do is in our completed assets folder, there's a folder called Scenes. And yours will have just this level 1 5.x in it. Let's open that up. And here we've got basically the finished version of the survival shooter game as it would be if you had completed the tutorial. And if you're interested in the survival shooter game, check out on the Learn site. There is a complete project, series of tutorials walking you through setting this game up and putting it together. So what we're going to do is we're going to start by modifying this a little bit. We're going to take out the enemy manager and the various spawn points. So I'm just going to deactivate those, so we're not going to have new enemies spawning all the time. And then I'm going to go into the prefabs folder and I'm going to grab the Zombear prefab, drop it in. Let's just move it over a little bit. And we're going to turn off the existing movement script as well as the existing attack script. So we're not going to cover attacking in this tutorial, just movement. But so I want to take off the original ones. Now, he's got a, let's switch to the scene view. And with Zombear highlighted, I'm going to push F to zoom in. Let's get a good view on him. He's got a trigger collider around him that was previously used to cause damage. I'm going to use that as his alert radius. So I'm going to up the radius to 5. So now if the player gets within the volume of this trigger, he's going to go into his yellow alert mode and start rotating and searching. Okay. And the other thing that we're going to do is we're going to set up some waypoints for him to navigate between. So these are going to be the points that he's going to walk between when he's patrolling. So I'm just going to make an empty game object. We'll call it waypoint. And let's give it an icon over here. We'll make it green. And I'm just going to move it over a little bit. And I just want to get him to have to walk through some of these obstacles. So I'm just going to kind of, and I'm hitting Command D to duplicate these, Control D, or Command D, depending on if you're on Mac or PC. And then we'll put one more like over here. So he's going to navigate between these in order, and we're going to write a script that's going to cause him to do that. And let's just take these and put them next to each other in the hierarchy. Okay. So now we're going to get into some, and so let's save this as, I'm going to save this as incompleted asset scenes. We'll call this complete SM. You could call it complete SM. I'll call it complete SM3 because I had a couple previous run-throughs of this. Okay. Now, that should be good for that. Now, in the scripts folder, I am going to create, actually here, let me delete my old ones. I'm going to create a new folder called State Machine. Open it up, and inside I'm going to create 5 C# scripts. We're going to start with our first script, which is going to be called, let's pull up my notes here. Our first script is going to be called iEnemyState. And so what this is going to be is what's called an interface. And so an interface allows us to establish a sort of a code contract between our different scripts, so that in this case, so that we can use our different state classes interchangeably, because they're all going to subscribe, they're all going to implement this interface iEnemyState. So we can delete this. We're going to change the name of this to iEnemyState. This does not need to be a mono behavior. It's not going to inherit from mono behavior. It's just going to be a C# class. And then in it, we're going to list the methods or the functions that our different states are going to implement. So in order for something to qualify as an iEnemyState, it's going to need to have an implementation of each of these functions. So we're going to have void onTriggerEnter, which takes a collider called other. We're going to have void toPatrolState. So this is going to allow us to transition to the patrol state. Void toAlertState, which allows us to transition to alert. And void toChaseState. So each of our state classes are going to need to implement each of these functions, even if they are an empty implementation, so that we can rely on each of those states to have all of the same functions, so we can use them interchangeably in our final script. So what we've got here, right, we can see that this is an interface, not a class, right? It is not inheriting from monodevelop. And now we've got a list here of the functions that each of the classes that implement this interface are going to be required to have. Nice and simple. Okay, so let's jump back to Unity, and I'm going to create a C# script, which will be our first state. So we're going to call this patrol state. And I'm going to open it up. And so the first thing that we want to do is, instead of making this a mono behavior, this is going to be an I enemy state, right? So this is now saying this must replicate, this must contain these functions. And so I'm actually just going to copy them and replace what was there. And then we just need to add public to each of these. I'm just going to copy and paste it. And we need to add some braces. Boop, 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 boop. Okay, so now this is going to be compatible with our interface, right? This now implements that interface. And so what I'm going to do actually is I'm just going to copy this whole thing, select all, copy, and I'm just going to make my other states since they're all going to start out just like this as well. So this is a little different from the way I usually do things where I kind of take one script and go all the way through, but you'll see it's going to make sense and it's going to go faster this way. So I'm going to make alert state and chase state. And let's open up alert state. Select all, paste. We're going to change the name of this to alert state. Save it. And do the same thing for chase state. Paste. Call this chase state. Save it. So now we've got these three classes and our interface. So before we continue, I'm going to set up our last script, which is going to be the actual state machine that's going to hold all the variables. So we're going to go ahead and create a C# script, which is going to be called state pattern enemy. Ebony state pattern enemy. Okay. And so we're going to flesh this one out a little bit first before we write our states, because we're going to reference some variables that we're going to need here. So this is a mono behavior, right? It's not an interface, and it's not implementing that interface. This is just going to be a regular Unity mono behavior. So, okay, so let's get some variables down. So we're going to have a series of public variables. We're going to have a public float called searching turn speed. So this is in alert mode, the speed at which he's going to turn around to look for the player. We're going to have a public float called searching duration, how long he's going to search for the player in alert mode. A public float called sight range, which is how far he's going to rate. Let's make it 20. How far he's going to raycast looking for the player. We're going to have a public array of transforms called waypoints. And we're going to have a public, oh, that's something I forgot to do. We're going to have a public transform called eyes. I'll do that in a minute. That's just going to be an empty game object at eye level for the enemy, just so that we're casting from a kind of a sensible place for him to be looking from. We'll do that in a sec. And then we're going to have a public vector3 called offset. This is just going to be initialized to a new vector3 0.50. This is just basically to lift as he's looking so that he doesn't look at the player's feet and hit the floor. It's just going to give a little offset so he looks kind of at the player's head. And then we're going to have a public mesh renderer called mesh renderer. Let's call it mesh renderer flag. And this is for the cube above the enemy's head, which I need to add as well. That's the other thing I forgot to add. And then we're going to have a bunch of variables that are public but hidden. So we're going to use hide in inspector, and we're going to have a public transform called chase target. And so we're going to store a reference to the player's transform here so that the enemy knows what to chase. And then I'm just going to copy this bit so I don't have to type it again and again. We're going to have our interface, right? We're going to have a variable to store an enemy state called current state. More about that in a minute. And then we're going to have instances of each of our states, right? So we're going to have a public chase state called chase state. we're going to have a public alert state called, you guessed it, alert state, and a public patrol state called patrols. What? No, not uppercase, lowercase, right? Patrol state. Oh, come on. Okay, there we go. Autocomplete for the win. Or the lose, as that may be. Okay, public. And then we're going to have a public nav mesh agent called nav mesh agent. And so we're using navigation in this pretty extensively. I don't want to spend time talking about that because I just did it last week in the click to move training. So if you want to bone up on navigation, please either hit the documentation or check out that training, which actually uses these same assets and should cover it. All right. So the next thing that so that's all our variables that we need. The next thing that we're going to do is we are going to add an awake function, which is called before start, and we're going to initialize our states. So we're going to say chase state. Oh, did I make that upper? No, I don't want that to be uppercase. That's confusing. Lowercase, please. Chase state equals a new instance of chase state, and we're going to pass in the parameter this. Now, we haven't set up the constructors for each of our classes yet, but in the constructor, we're going to have it listen for a state pattern enemy so that we can create a reference between this script and that script here in awake. And you'll see that in a minute. It'll become more clear in a minute. We're going to do that for each of our states. We're going to say alert state equals new alert state this, and patrol state equals new patrol state this. And then we're just going to get a component reference to our nav mesh agent. We're going to say nav mesh agent equals get component nav mesh agent. So this is just getting a reference to the nav mesh agent component that's already attached to the enemy. So we can issue navigation commands. Okay. And you'll see this class is actually really pretty simple because most of the behavior is going to be in the states themselves. So in start, we're just going to say current state equals patrol state. So the first state that the enemy is going to transition to when it starts is patrol state. And right, that's why we're using awake and start, because awake is going to get called first, and then in start we can refer to patrol state, right, because it's already been initialized. Okay. In update, this is kind of where the magic of this setup works. So in update, we're going to call current state dot update state. Now remember, because of the interface, each of our classes has a function called update state, right? So now every time we call, every frame that we call update in our state pattern enemy, it's going to call update state on whichever state is the current state, right? So now we can switch between these states and just keep calling update state, which is going to do a different thing in each of the states. And this is kind of the heart of this pattern and why we're setting it up this way, so that we can just say, I just want a state. I just want to be updating a state, any state, and I can be sure because of enemy state, because of my interface, that whatever is currently in current state is going to have the function update state. So that's kind of important little detail there. So next, we're just going to have a private void on trigger enter, right? This is just a callback, a mono behavior callback, which is going to be triggered whenever, in this case, the player, or well, anything really, but we'll check for the tag of the player, enters that trigger that we set up on the enemy. And then we're just going to say current state dot, again, on trigger enter, and we'll pass in the collider other, right? So notice here, we have a function in each of our states called on trigger enter, but because it's not a mono behavior, this would not get called unless we had a mono behavior that also implemented on trigger enter and then called that function. So we could have actually called these like on trigger connected or whatever we wanted, because really this is just a function that takes a collider parameter that we're calling from here. We just use the same name because maybe it's easier to understand. But that's why instead of calling this just to kind of disambiguate, I called this update state instead of update, just so we can kind of see the difference there. I maybe should have changed that. I don't know if it's more clear or less clear, but anyway. All right, and so that is it for our state pattern enemy. So really, it's just allowing us to use some of the stuff in mono behavior and storing all these variables to set up our state. So now, what we're going to do, so patrol state is going to have a couple of private variables. So we're going to have, first of all, a private read-only variable of the type state pattern enemy called enemy. And this is actually going to be in each of our state classes. What's unique to this is a private integer called next waypoint. So this is going to be, we're going to count through the waypoints as we move through the waypoints in the array, and this will say what's the next one that we want to move towards. Okay. So I'm going to start by writing, there's a function that we're going to call from update state called look. So let's implement that first. So we're going to say private void look. And so we're in patrol state, right? Our guy is patrolling between the waypoints, and each frame he's raycasting in front of him, in this case 20 units, to see if he can see the player. And if he does, he's going to go out of patrol state directly into chase. Whereas if the player enters the trigger, he'll go into alert. So in look, we're just going to start by declaring a raycast hit called hit, which we're going to store data about what we hit with our raycast in. And then we're going to say if physics.raycast from, oh, this was happening to me last time. It doesn't want to autocomplete properly. Oh, okay, I'm just going to type it out this way first. This is going to drive me crazy. From enemy.eyes.transform.position in the direction enemy. Arg. This is going to drive me nuts. Enemy eyes.transform.forward. And then we're going to use the keyword out to store a reference to the thing that we hit in our raycast hit. And then we're going to do it over enemy. Oh my gosh, please, can you autocomplete, please? Enemy.SiteRange. Yeah. Okay. Boy, that's going to be annoying. Okay. And hit, we're going to check. So if we saw something, right? So the physics.raycast returns a Boolean. So it'll be true if we saw something. And then we're also going to check, is the thing that we saw tagged using compare tag player. Going off the screen here a little bit. It's okay. So we're going to use compare tag player. Have some braces. Whoosh. This is the problem with having everything so big. And then we're going to say enemy dot chase target equals hit dot transform. So chase target is going to be equal to the transform of the thing we hit. So basically start chasing the transform of the player. And then we're going to transition to chase state, right? So we're going to call our toChaseState function. All right. And that's going to be it for look. And so now let's call that from update state. So we're going to be calling look every frame. And then we're also going to have void patrol. And this is what's going to move us between our waypoints. So we're going to say enemy.meshRendererFlag.material.color equals color.green. This is just really for display, right? So we can see what state the enemy is in. More like a debugging thing almost. You don't need it in your final game necessarily. And then enemy.navMeshAgent.resume, right? Start walking again. And then, actually, we could do this first. Let's set the destination first. And then enemy dot navmeshagent dot destination equals enemy dot waypoints next waypoint, right? So the destination is equal to the position of the next waypoint in the array. And then we're going to check if we got there, then we're going to want to transition, then we're going to iPhone generation, that's what I wanted. If enemy.navmeshagent.remaining distance is less than or equal to enemy I'm just going to keep going. .navmeshagent.stopping distance. I don't know why sometimes it autocompletes properly and sometimes it doesn't. No, not enemy tag. Good lord. Okay, I should just copy. I'm just going to copy enemy dot. So I just have it in my clipboard. And not enemy.navmeshagent.path pending. So basically, is the remaining distance less than the stopping distance, and do we no longer have more path that we're trying to walk, right? So basically checking if we've reached whatever we were trying to walk to last, which waypoint, and then we're going to say next waypoint equals next waypoint plus 1 modulo enemy dot waypoints dot length. So basically, we're using the modulo here to loop back around in our array. So once we get to our third waypoint, we're going to our waypoint 3, our fourth waypoint, we're going to go back to 0 and start the process again. And so what's nice about this is we're not using a hard-coded number of waypoints, so you can have as many waypoints as you want, right? Waypoints.length will just get bigger as you add more waypoints, and it should work nicely. Okay, so that's patrol and look. So now we can call patrol from update state. Now let's go back up to the top of the class and let's fill in the other stuff that we need. So I should have actually done this first. The first thing that we need is the constructor. So we're going to do public patrol state, and it's going to take the parameter state pattern enemy, and we'll call this lowercase state pattern enemy. So, and then when an instance of this class is created by state pattern enemy, it's going to pass in itself, right, which is a state pattern enemy, and then we're going to set enemy, our private variable enemy, to equal state pattern enemy, right? So in this line of code here, patrol state equals new patrol state this is going to get passed through here so that this now becomes the enemy that we're referring to, right? So this is how we're going to communicate between the different states and the main state pattern enemy script. So we're going to say enemy equals state pattern enemy, and then in onTrigger enter. So in patrol state, right, we're going to check, like let's say the player walks up behind the enemy, and we could like say that maybe he hears him, right, because he gets close. So we're going to say if other.gameObject.compare tag player, then we're going to go to alert state, right? We're going to transition from patrol state to our alert state if an object tagged with player collides with the trigger. In patrol state, we're just going to make a debug.log statement saying can't transition to same state. So just, this is very unlikely to happen, right? But we do need to have an implementation of to patrol state because of our interface, right? So we'll just put a little warning message there because we can't transition to the same state. So then into alert state, this is going to be really simple. We're just going to say enemy.current state equals enemy dot alert state, right? So we're now going to be setting our state pattern enemy, the current state variable of it, to the instance of alert state that we initialized. And we're going to do the same. So actually, we can go to chase from patrol if we see, right? If we look and see the player, we can do enemy.currentState equals enemy.chaseState, right? And so now you can see it's actually going to be very similar between the other states, right? So this is the patrol state, but we're going to have a nearly identical architecture in each of the other classes, just with a few different details of implementation based on what the enemy is supposed to do in each of those states. So let's do alert state. And I'm going to do a little copy and pasting. Usually I don't do that, but I've got a lot of stuff. I want to go through it quickly. So we're going to copy the constructor. In fact, we can let's copy this whole block. I don't need all of it, but so in alert state, I'm just going to paste that. We don't need this. And we're going to change patrol state to alert state, and then the rest of the constructor works, right? So we need this private variable, and then we just need to do the same initializing of enemy using the constructor here. So we're going to just keep that the same. And then alert state is actually also going to have the same implementation of look. So I'm going to copy that and put that at the bottom here. It's not going to have patrol. That may be, is that everything we can copy? Let's see, I think I can copy to chase state as well, because that's the same, right? Because we can go out of alert into chase. So let's just copy to chase state, to alert state. We can just copy our warning, because we can't transition to ourself, right? All right. I think that's all the copying I can get away with here. And now let me pull up my notes for alert state. Okay, so the unique variable we're going to need to add here is going to be search timer. So this is going to be a private float called search timer, and this is basically just once the enemy starts rotating and searching, we're going to add to this, and then after a certain number of seconds have gone by, he's going to stop searching. Okay, so in update state, we're going to call look, and we're also going to have a function called search, which is going to be unique to this class. So we're going to have a private void search. And then, where is that? Okay. And some of it is going to be the same. I'm just going to copy the bits I can copy. We are going to, maybe that's the only piece. Yeah. We're going to change color, but we're going to change to color dot yellow. I think that's the only bit that's the same. We're going to call enemy.navmeshagent.stop. Let me just copy my enemy dot in case it starts messing with me again. And then we're going to say enemy.transform.rotate. So this is going to cover our spinning around looking for the player. 0 on the X. And then on the Y-axis, enemy.searching turn speed, which in this case is set to 120, times time.delta time. So basically, this is just going to rotate us around the y-axis each frame. And then we're going to increment search timer. So we're going to say, what did I call it? Search time? That's okay. Search time plus equals, let's just fix that. Search timer plus equals time.delta time. So we're adding time.delta time to search timer, and then we're going to check if it's gone over our duration. So we're going to say if search timer is greater than or equal to enemy.searching duration, we're going to go to patrol state, right? So we've been searching for our 4 seconds that we set here in searching duration. Once we've searched for 4 seconds, we've spun around for 4 seconds, we're going to give up and start patrolling again. All right, so that's search. So let's copy search, and we're going to call search every frame while we're in the alert state. So every frame we're in alert, we're going to be rotating around and looking. And then let's go and fill in the blanks here. So, okay, state pattern enemy, look, search. On trigger enter is the thing that we're using to transition to search mode. I'm just going to leave it blank. We could put a warning there as well, but I'm just going to be lazy and not. Into chase state, we just need to add one thing here, which is to reset search timer to 0, right? Because we've stopped searching. We might have seen we saw the player, right? Maybe midway through our search. We're going to reset the search timer because now we're going to chase. To alert state, we've got a warning. To patrol state, we're just going to say, we just copy this. And we're just going to go to patrol state, right? So we're just going to change the state to patrol state and also reset the search timer. Save. All right, so that one's good. And then let me look at the chat. Hassan Smala says, could we use another name instead of I enemy state? The reason that using the I is useful, because if you look here, we're implementing I enemy state. If you didn't have the I there, you might think that this was just inheriting from a class called enemy state, right? So the I is just a way to indicate that this is a interface implementation as opposed to a regular class inheritance situation. Just kind of a convention, but you could actually leave out the I, but you just might get confused, or other people might get confused. Okay. Yeah, the fact that we have state in the name and I in the name of the interface are purely style things. You could do without them if you didn't like them. It's just to make it easy to read and understand. All right, so in chase state, let's just we'll grab the same block from the top here. And we're just going to make this chase state. Chase. We don't need search timer. And then in update state, we're going to have look as well. Look is actually going to be implemented a little bit differently, but I'm going to copy it because it's a minor difference. So look. So what we're going to do in look in our chase state is that we are going to add a couple things. We're going to add a vector 3 called enemy to target. And this is going to be equal to enemy, just copy that, enemy dot chase target dot position plus enemy dot offset. So that offset that we made. So we're going to calculate a vector from the position plus the offset to the eyes, or from the eyes to the position. Eyes.transform.position. I know I haven't put the eyes in yet. I'll put them in. So that's just going to get us the direction from the eyes to the target. And then we're going to use that instead of transform.forward here, right? So when he's in patrol and alert, he just always looks forward. In chase, he's going to be a little smarter. He's going to actually look at the player, even if the player moves around a little bit. So we're going to put that vector instead of transform.forward. And then, yeah, here, chase target equals hit transform, and then we don't need to transfer to chase state because we're already in chase state, right? But what we are going to add here is we're going to add an else, so meaning if this check here returns false, right? Meaning we raycast and we don't hit the player, or we hit something else, right? More likely that the player got behind something to get out of the way. Then we're going to go to alert state, right? So we're going to go back to alert state, circle around, and then if we don't see anybody, go back to patrol. So here we're going to have, and then let's add, so we'll call look in update state. And then we're also going to have a chase function. So we're going to have private void chase. No, what did I do there? Oh, did I put it? Oh, wrong spot. Weird. Okay, what? Did I not? Let's just see. I don't know why it's indenting weirdly there, but let's see. Did I miss something here? Oh, what? I probably missed a brace somewhere. Hold on. Else. Look, else. That's the end of that. Okay. I think that was the problem. There we go. Durr. Excuse me. Okay. Then. So if you're trying to figure out what's going on with your braces, right, just click on a brace and it'll show you the opening and the closing brace, the opening or the closing brace for it, which is what I was doing there. Okay, here we're just going to say enemy.meshRenderFlag.material.color equals color.red, right? We're going to turn our cube flag thing red. Enemy.navMeshAgent.destination equals enemy.chaseTarget.position. And enemy.navMeshAgent.resume. So basically, we're just going to say chase the player, right, which is stored in chase target, and start moving again. That's going to be our chase function. Nice and simple. And then we're going to just call that every frame. While we're in chase, we're going to execute that every frame. And let's just review a couple more things we need. Look, this does not need an implementation for on-trigger enter. You can't go to patrol from chase, so we can leave that blank, or we could put an error. We can go to alert. That's actually the only state we can go to. So we're going to say enemy dot current state equals enemy dot alert state, right? So the only state we can transition to from chase is alert. And to chase state, we could put an error, but I'm not going to bother. Okay, let me just review this, make sure it looks right, and then I'll take some questions. Yes, this all looks good. Okay, good. So that is our script hopefully done. I'm sure there's going to be some nice errors for me to fix since I just scripted away for 49 minutes. Yeah, we go. Undefined symbol. Let's take a look. What did I leave out there? Vector 3. Would I leave out a bracket? No. Yes. Or did I just didn't need this, right? Lots of errors. Yay. Let me look at the chat for a sec. Yeah, so somebody's asking, like, why are we doing this way? What we're avoiding is a ton of if statement spaghetti, right? So let's say we're in chase state. We do not want to have to check, if current state equals chase, and such timer is not elapsed, or blah, blah, blah. It just saves us a lot of spaghetti. And this is going to be much easier to extend. And I'll show you a little bit of that once I get all my errors fixed. Why is that? It's got it the same for all of them. State pattern enemy. MonoDevelop liked it when I wrote it. State pattern enemy, private read-only state pattern enemy. Let me just save. Save them all. That may be. Sometimes saving everything helps. Oh my God, it works! Hallelujah, praise Jesus. Okay. I can walk! All right. So, let's see. He can't walk. That's okay. That's to be expected. So, let's go. All right, so we need to add our cube. Let's add our cube flag. Oh, thank God it was something easy. In the hot seat. Live from the hot seat. Okay, let's put that up there. And we're going to child it to the Zombear. Bow. Oh, not you, Windows. Okay, that is good. we'll just drag this. Oh, I didn't add this to the guy yet. Let's add it. I'm going to drag our cube. Let's just call it flag. Flag. And then we're going to drag in our waypoint. So I'm just going to lock the inspector for a second, grab, shift click to grab all these guys, and boop, drop them right into the array there. Look at that. And the rest looks good. Unlock. Let's see if it works. No. Oh, eyes. We didn't do the eyes. Had to be something, right? Game object, create empty child, eyes. And we're going to put this at 0.9 and 0.4. So it's just kind of in front. We'll give it an icon. There we go. As. And there we go. Boop. All right. Let's give it a try. Yes, look at him go. He's chasing. He's chasing. All right. Whoop, run for cover. Okay, you see we got behind that thing for a second. Okay, there we go. We're safe. We're safe. And he's back to patrolling. He sees us again. He smells us. Now he's back to patrolling. And surprise him. Hi, I'm over here. No, I'm not. I'm over here. He's going back to patrolling. Yeah, so there we go. It's working. And he'll just keep chasing us. Can't do anything to us, really. It's not a very intimidating monster. Just a little sock puppet, really, but... whoop. And so, there you have it. So, just as a... And so then, if we want... Let's say we want to add another state to this, it would be... Let's say we want to add an idle state, right? I'm not going to actually do it, but all we would have to do would be add a void to idle state to our interface, right? And then a function to transition to idle state to each of our existing states, and a variable and so on to the main state, right? But then we could just keep adding states if we wanted to, and it's the state knows about itself, right? So the idle state could it could sit and think about its life and its feelings. There could be a bunch of complicated code in there that wouldn't have to touch any of our other states, right? So everything is just nicely packed into their own scripts, and we can kind of move between them as we see fit. So, yeah, that is our show for today. I'm going to hang out in the chat for a second and answer some questions. But for those of you who are done here, thanks for watching. TimeLog asks, wouldn't a base state class be better than an interface in this case? Seems like most cases have the same basic method implementations. You totally could do that. You could do this with inheritance as well. And if you Google around for like C# state machine online, you'll see people doing it that way. So that's another way to slice it that would also work, if you prefer that approach. Adam asks to reiterate how it sets up the states. So with the keyword this, right? So what's happening here in awake, right? When state pattern enemy, when the object it's attached to, in this case our enemy, becomes enabled for the first time, awake will be called as the very first thing, right? And when that happens, we're going to let's just look at chase state. Chase state is going to equal a new instance of chase state, right? So we're going to create a new instance of our class chase state, and we're going to pass in this, meaning this instance of state pattern enemy, as a parameter to the constructor, right? So here. So in the constructor gets called whenever a new instance is created, right? So as soon as we instantiate our chase state object here, this piece of code will get run, and as it so happens, we're passing in the parameter of the type state pattern enemy called state pattern enemy, and we're using that to set this variable enemy, which we're going to then use throughout our scripts to pass information back to state pattern enemy, right? So really there's almost no logic in state pattern enemy, right? It's just basically start up calling update state each frame for whatever state is currently active, and then firing off the triggers when the trigger collisions happen. CS Curios asks, could you explain the waypoint loop through in greater detail? Yeah, sure. So basically what we've got in patrol state, right? Every frame we're calling patrol, right? And in patrol, we are setting the destination of the nav mesh agent, right? Which is the next place he wants to walk to be at this index in the array, right? So we're using the number next waypoint to specify which of these waypoints we want to use the position of, right? These guys. Whoop. So whatever he's currently trying to walk towards is going to be next waypoint dot position, right? That's the destination, and he's going to walk, and then as he walks, we're going to continuously check, is the remaining distance for the nav mesh agent less than the stopping distance? Meaning, has he got to where he's going? And has he run out of path? Right? And the path is the sort of imaginary line that's drawn between the two waypoints by the navigation system. And that's handled basically automatically by nav mesh agent. You just say, this is the destination, try to figure out a way to get there. And then, so if we've determined that we're within stopping distance of one of the waypoints and we no longer have a path to walk, then we're going to add 1 to our next waypoint, right? So we're going to say next waypoint plus 1. So if we're on waypoint 0, we're going to go to waypoint 1. And in case we had gotten to we'd looped through this 5 or 6 times, we're using the modulo to just say divide waypoints dot length by itself, and then whatever's left over, use that number, right? So next waypoint is going to be equal to the remainder of this operation. So basically, even if we're on waypoint 9, it's just going to say, okay, divide that by 4 twice. So really we're on waypoint 1. The remainder for that would be 1, right? No matter how many loops we've gone through, the remainder is always going to be a number between 0 and 3. C. Strachan asks, so if you have, for example, 30 states and you want to add one more, you have to go through all 30 states and add the new 2-state function. Yes, you do. There might be a way to avoid that, but I don't know what it is. But good Lord, man, 30 states? That's a lot of states. GM Liquid Media asks, do you need to run look and chase in update? Could you use IEnumerator like a coroutine? I have seen lots of CPU usage running every frame. Absolutely. I'm being a little bit lazy, and this is probably not the most performant way to do it, raycasting every frame, especially if you had lots of enemies. What you could do is, this is more about the state pattern, right, as opposed to the specific implementation here. So do take that with a grain of salt. You could just have a coroutine instead of update, and you could call, current state.update every 0.1 seconds or something, which would be whatever it is, 10 times more performant, for example. This script is assigned to the enemy. Yeah, the state pattern enemy is actually the only script that's assigned to anything. State pattern enemy is assigned to the enemy, and the rest are just sitting in the folder. Yeah, guys, just take it from me. As somebody who's done the if statement thing, a million nested if statements, it's just horrible. So this is directly trying to solve my own pain as well. And also for I'm working on my personal project. I'm just trying to do basic stuff. I've got the basic gameplay together, and I'm just trying to make pause, a pause menu and a loading menu and all this stuff. And just having to check if is paused, but not in main menu, and all this BS is just like a nightmare. So I'm actually going to go through and rewrite it all using this approach pretty soon when I get a little free time, because it's just a lot cleaner. I am not shouting. Good to see you. Asks, will the Unite Learn sessions be up on the archive like the survival shooter? Yeah. Yep. Well, yeah, I'm pretty sure we will. The training day, you mean? I'm pretty sure we're going to videotape that and put the archive up just like we did last year for survival shooter. And then obviously all the Unite talks will be up as well. So there should be, like, after Unite Boston, there should be a ton of good new video content for you guys to watch. Yeah, and keep in mind, guys, this, I just want to show an example of state machines or finite state machines. There are other approaches to enemy AI. As Adam says, there are behavior trees, neural networks, a bunch of other crazy stuff that you can look at, that will give you other approaches to AI. This is a relatively simple one, but hopefully, a nice, clean, and tidy implementation of it. All right, guys. So what I'm going to do is I'm going to turn off my microphone, but I will hang with you guys in the chat for a little bit longer. Just keep an eye on it and see if anything else comes up. So if you have any last questions, fire them off. And as always, to all our new people, welcome. And to all the returning regulars, great to see you all again. Bye.